Hi, I'm Bob Alsop of ShopSabre CNC. Around here they call me RouterBob. Today we're going to take an in-depth walk around of the ShopSabre ISM Series CNC router. The ISM Series machines were actually derived from our really successful IS Series. Both are members of what we call our machine tool grade router family. Here's what that means. First off, the base frames are structural steel. Now the ISM has heavier steel because the machining loads are much heavier because of the high-speed machining. They're all welded, they're one piece. And one of the things that amazes me the most is when I look inside of these frames and I look at the welding. The welds that you see inside are just as good as the ones on the outside. You know, a welder's signature is his weld, and it just tells you how much pride the welders at ShopSabre CNC have. Now, once you have that frame assembled, then the next step is to mill it, and these are milled in a single setup on an aerospace mill. That means these frames have the same accuracy that aerospace mill has. Like the base frame, the gantry and gantry supports are welded mill structural steel. Now we use that material for a reason. It gives us extreme rigidity that has a direct impact on your edge finishes, the accuracy, and also how much you can put underneath the gantry. Now in that milling process we create what are called datums. What those datums are the surfaces for the precision contour guide rails to mount on. Now let's talk about those. We use precision contour guide rails in all the motion axis. And here's why we do that. They're actually based on ball bearings. And the ball bearings recirculate in the bearing trucks and there's no play. So they move really, really freely, so it's easy to move things around and accelerate and decelerate, but there's no play there. So that's why we use precision contour guide rails on these machines. All of our machine tool grade routers feature ball screw technology. Let me unpack that a little bit. First off, ball screws are based on ball bearings, just like we used on a precision contour guide rails to make sure there's no play in the axis motion. The same thing happens with ball screws. So we have a ball nut that rotates, and between the ball nut and the ball screw itself are recirculating ball bearings. And once again, they're slightly larger than the channels that they run in, and that's called preload, and there's no play. What this gives you is unbelievable accuracy because there's no play. That directly relates to edge finish, and that directly relates to your machine accuracy. That's why we use them in these machines. The ISM Series is equipped with some upgraded Mitsubishi closed-loop digital servos. Let's talk about that a little bit. Here's what closed loop means. Closed loop means that it feeds information back to the controller. So the motors and the controls are constantly talking to each other. And each one of those motors has its own drive. Now on those motors also you have glass encoders. And there's actually 1 million counts per revolution. That's how much data is available. And that's what makes these machines so accurate and so powerful. The final part of machine control has to do with the control itself. The M in ISM stands for Mitsubishi. These machines have the Mitsubishi M80 control, which they advertise as the fastest machine control in the world. But let me tell you the story of how we arrived at this. We knew for this level machine we were going to have a full-blown machine control. So we looked at almost everything on the market and we narrowed it down to 2 machine controls. And one of them, of course, was Mitsubishi because that's who won the test. But we brought both of those controls and put them on our machine and actually did tests because we wanted to see the test cuts. And Mitsubishi won, and it wasn't even close. So that's how the control got here. Let's talk about why these controls are so fast. Well, it's about data. We talked about how much data is coming out of the encoders off the drive motors. All right, the control can use that data to make some determinations. And the way it does it so fast is it's actually transferred fiber optic internally. Now you got to watch some companies say their controller's fiber optic, but they got one little cable in there and the rest of it's wired. These are not that way. So let's look at what we've got. We've got the ability to analyze all that data. Well, what do? What happens, for instance, if a tool starts to develop harmonics? The control from that data can determine it and make determinations on loads to eliminate that. So that's one of the reasons we can get so much more performance because the machine control can adjust for that so you never see a defect in the edge finish. There's a human part of machine control and it has to do with how the operator interfaces with it. Now, traditional machine controls historically have a reputation of being somewhat complicated to operate, and that really concerned us at ShopSabre, because we actually developed a ShopSabre machine control interface that's tremendously successful. And the reason it's successful is because everything's on a single screen. So you don't have to have an engineer to run it, you just have to have a good employee that comes to work every day, and they can be successful really, really quick. So we wanted to protect that, and we probably spent more time with Mitsubishi working on that part of the system than anything else we did, but we were able to create that experience. Now, if you prefer a traditional interface, it's behind the scenes that you can turn that on, but I can't imagine you using that system when you see how good the new system is. The final part of machine control has to do with what we call connectivity. That means how you get programs in the machine. Well, first off, the machines use standard G code, so any of your programming softwares can output to it. There won't be any problem. But then how do you actually get the programs in there? Well, there's a number of different ways. You can actually plug your laptop in and send the programs directly to it. We even put a ledge on the control stand to set your laptop on. There's also a USB port that you can transfer files in. There's SD cards that you can use to transfer files in. You can even just plug the network into it and transfer all the data in and out through the network. So we've made a really, really convenient system for the connectivity issue on machine controls. We developed an exclusive feature at ShopSabre we call Super Z technology, and let me tell you how that came about. It all started with, we said, you know, so many CNC routers, they put a pretty high gantry, but you can't really machine under it because you don't have enough travel in Z. So we said the first thing we want to do is increase that. And so we have finite element analysis in our engineering system, and so we said, okay, well, let's create a structure that will allow us to extend that down without losing rigidity. And we did that. And the stiffeners that you see on the machines were the result of that. That came directly out of finite element analysis. So that was really the first thing that happened. The consequence of that is if the part fits under the gantry, you can pretty much machine it, okay? The next thing has to do with speed. Now, people don't understand typically that 3D machining is determined by the slowest axis. So no matter how fast you go in X and Y, Z is almost always going to be slower, and that's going to determine how fast 3D machining is. So we said, well, if we could improve that, we can machine 3D faster. Here's how we did it. We said, okay, well, what's the problem? Well, we've got all this mass that's the tool plate. It's a spindle. It's all those things that we're raising up and down on the guide rails. And so the ball screws have to raise that. So we said, well, wait a minute. What if we could counteract that mass? And that's what you see with the balancing cylinders. So the balancing cylinders neutralize that mass. So it makes it real easy for the ball screw to raise and lower. That means we can increase the acceleration and deceleration. That makes it machine faster in 3D. And it's not just 3D, it makes tool changers faster. It makes drilling faster. All those things are faster because of that. So that's the second part of Super Z. So we packaged all this together and we called it Super Z technology. Looking under the hood of the ISM series, we find the HSD spindles. Now they're offered in a couple varieties. One is a non-tool changer version. We also have them in automatic tool changer versions, and those basically then are offered in two varieties, one with an ISO 30 tool holder or an HSK tool holder. Now if your application requires a lot of high-speed drilling, the optional multi-drill might make a lot of sense for you. Related to automatic tool change actually has to do with the tool changer itself. Now, when we developed the ISM, we wanted to change the workflow on the machine, so instead of having a tool rack in the back, we created a rotary tool changer that mounts to the gantry. And let's unpack that a little bit. If you go through all the machine tool industry, the number one service problem is tool changers, but it occurs in two areas. The first area has to do with positioning. So normally you'll have a carousel on a slide and it slides to the active or inactive position. And if you've got a slide with two positions, you have to have two sensors. And if one of those sensors quits working, you don't have tool change anymore. The other area has to do with the rotation itself, and there's almost always some mechanical device that's involved, and the machine control just simply says rotate one position, and it does that, and the control tracks it. Those are the two sources of problems. Well, We challenged ShopSabre Engineering to solve those problems and give us a rotary carousel that did not have those problems. And here's how we did it. First off, we were able to extend the gantry so that we could extend the movement of the head to take care of the slide. So I don't have to have a slide to get in position. So we use the X and Z axis to do all the motions that are required for the tool change. Now, to actually make the disc rotate, we said, why are you using mechanical stuff? I could actually use an AC digital servo from Mitsubishi with the same glass encoders that the big drives have, and I can rotate that, and that machine control knows exactly where that is at all times. And not only that, it can spin it really fast, and I can actually go the closest direction to the tool itself. What that amounts to is really, really quick chip-to-chip tool changes. And that's how we developed this new control system. The final part of our ISM walk-around has to do with the machine table. Now, this machine has a phenolic table. Now, there's an option it doesn't have that's really popular that we need to talk about, and that's the Tslot option. It basically allows you mechanically to clamp parts on the table for machining. Now, there is a really popular option this table has, and that has to do with what we call part locator pins, and it makes it real easy to get your material correctly aligned on the table. Now, if you look at the table, you notice there's some machining on it, and that's because this is a vacuum table. And let's talk about how that whole concept works. When we get into panel process, it's all based on what's called flow-through fixturing, and here's how it works. First off, our number one goal is to get as much vacuum to the underside of the part as we can get, and that's done with our high-flow vacuum system, and here's what it consists of. First off, we only use rigid tubes because we don't have losses that you get with flexible tubes. And we make sure everything that supplies the system is large diameter. So first off, we have a 4-inch tube that actually goes to this frame member that's integrated in. That could be considered a vacuum plenum or even a tank. And then there are actually 4 valves that come off the top of that. Each of those then goes to one of the 4 vacuum zones, and there's 2 ports per zone. So the idea is to get as much vacuum to this surface as possible. Here's how the technology works. We start out with a piece of 3/4 MDF, and we fly cut, which means take a thin layer off both sides. So what that leaves you is a piece of MDF that's real porous. We lay that on the table. Then we put our panel material. That could be melamine, it could be MDF, it could be plywood. When we turn the vacuum on, vacuum pulls through the MDF and it holds that part down. Now, so when we cut our parts out, we make sure we don't cut through too deep. We try not to cut through more than 0.010 of an inch so we don't create all these vacuum leakage channels. When we do that, the parts lay in place while we cut them apart, and the next sheet can be a totally different pattern, and the next sheet, and the next sheet. This is the basis of zero setup for nested base manufacturing. And finally, let's talk about the vacuum pump itself, and with this system, we recommend the optional Becker vacuum system. I hope you enjoyed the video. The ISM Series is a game changer for the industry. If you need more information, you can contact us at ShopSabre.com. If you'd like to see more videos like this, be sure to subscribe to our YouTube channel. Thank you for watching.